All right, so if you find the NASA.
Are you on a Google Meet too?
No, this is a screencast for the kids that are at home. The NASA exercise, Survival of the Moon. You skip all the way to the last page. It's called Earth on the Move, and it says notes and study. So 2 of the main ideas that'll be on the test when we get there, it'll probably be the Tuesday after we finish the iLearn testing, are rotation and revolution. And number 1 says rotation and revolution are both motions of Earth. So it tells you that that's 2 ways that the Earth moves in space. Because these repeat over and over again, we learned that they use these motions to mark periods of time. So how long is one rotation on Earth? What do we use that for time marking? How long does that take for us? One rotation. Anybody remember? One of these. The other one?
A week? A day?
Day, yes. So one rotation equals 1 day, which would have nighttime and daytime in it. Remember, we get confused a little bit with how they use the word day, right? In this case, it means the 24-hour period. So then what is one revolution on Earth? How long? A year. That's right. All right, and then down at the bottom, it says, in the space below, compare and contrast the rotation and revolution of Earth by recording unique features of each phenomenon on the far side of each circle. Record common features of Earth's rotation and revolution where the circles overlap. Hint, think about including examples that we've learned about in class. So, what is rotation? We learned that it's how long?
A day.
A day. So this causes day and night. How much time does that take? How long is a day?
24 hours.
24 hours. What's a good synonym for rotation? Turn. Some people say spin. And when we turn or spin, where or what are we spinning on or around? Like, what's the... No, there was a word for the center. Like if you could imagine like your spine in the middle of your body that you're spinning around, the pole that's sticking out of that globe. No, but it's another invisible line, not equator. The one that goes through the planet. I'm recording this for the people that aren't here. Starts with an A.
Atmosphere?
No. Axis.
Oh.
So if you said, well, where does it rotate? You'd say on its axis. So what does a revolution cause?
1 year.
1 year. How long does a year take?
12 months.
Or how many days?
Is it like 135?
Bigger.
185?
Mm-mm.
3? Is that the threes?
It's 300 something, yep.
375.
Close, very close. 365.
Wow.
And not a lot of people count weeks, but it's 52 weeks. And how do we move? Like, what's a synonym for revolution? We use the V. What word did we say would help us? It has a V.
Violent?
No, no. All right, how about describe the motion? If this is rotation, what do I do to revolve? No. Think of sports.
Run
Run where?
around a circle.
Yeah. So you got to travel around, like on a track, like running track. Has a V. Travel around. And what do we travel around?
The grass.
Well, when we run on the track, yeah. What does the Earth travel around in space? Huh? The sun. Yeah. So these are pretty specific to rotation and revolution. What could we put in the things that they have in common? Yeah. They happen in space. Huh? What is doing these two things? Huh? What's the thing that rotates and revolves? What are we talking about here?
Rotation. Atmosphere.
No, it's where you live.
Earth.
Earth. They're both how Earth moves. And they both help us mark time. So for the test, this is a page that you would want to take out to make sure that you know the difference between rotation and revolution. Most people remember that we spin and that we go around the sun, but because they both start with R, a lot of times people flip-flop them. So I use the T in rotation and the T in turn. So I remember that that's what rotation means. And I use the V in revolution and the V in travel. So I know I have to travel around to make a revolution. Okay. Any questions about that one? Okay. On the back, we have a little bit of a review dealing with the seasons. So unlike the other tests that you guys have taken, this test will be on paper. You will have to draw an example of rotation and draw an example of a year and the moon phases and the seasons. So that's why we've been drawing these diagrams together. So at the top it says, prepare a labeled diagram that includes a caption that explains how Earth's tilt and revolution around the sun cause each of the following: changes in the angle of sunlight hitting Earth's surface, and the seasons in the southern hemisphere to be opposite of the seasons in the northern hemisphere. So this explanation already tells you what the seasons are caused by. Our task is to draw it so that people can understand what this means and why it's the tilt and revolution that makes the angle of the sunlight change and the seasons to be opposite. And we've done this already in the book and on another notes page. So I would like you to put a sun in the middle of your picture space there. And we know the sun gives off its own light, so it gives off light all the way around. And it tells us that one of the motions we're going to have to illustrate here is revolution. How many seasons do we have as we revolve around the sun? 4, yeah. So draw an Earth over here. 1, 2, 3, 4. Now the notes page that we created about the seasons has a lot of information on it. And we're going to do something similar, but not include all of the information. I always like having my Earth tilt to the right. So They need to all be tilted to the right. This is the axis we're drawing. We don't wobble around in space. We stay tilted the same way. And we also need to know about our hemispheres because it says that the seasons are opposite in the hemispheres. So when we draw an Earth in a diagram, it needs an axis and an equator. Now, we don't want people to think that we think there's 4 Earths going around the sun. So let's put in our revolution arrow. And label it revolution. So in the instructions it says Earth's tilt. We've got the Earth's tilted and revolution. We've got the arrows for revolution. Now we have to look at A. Changes in the angle of the sunlight hitting Earth's surface. Where would the sunlight be hitting this Earth most directly, like at a 90-degree angle? The northern hemisphere or the southern hemisphere? Huh? Somebody said it. Southern, yeah. So let's draw an arrow from the sun towards the southern hemisphere. Most direct rays. Remember, that's right over the Tropic of Capricorn. So if the most direct rays are in the southern hemisphere, what season would we be in on this Earth position? The heat's on the bottom, so we would have the opposite. What would we be in? What season is it cold here? Winter. So winter for us, summer for them. Good. So we travel around and it takes about 3 months. Remember, this was December, January, February, March. What's March 21st is our first day of what? Spring. And we call that an equinox because the sun is most directly overhead at the equator. So we have spring. What would the southern hemisphere have? Fall. Good. So March, April, May, June 21st. Where is the sun most directly overhead? Above the equator, at the equator, or below the equator? Well, we went below, we went at. What should come next? Above. Yeah. Most direct rays. So if the northern hemisphere where we live has the most direct rays, what season would we be in now? Summer. So what would the southern hemisphere be? Winter. So we go June, July, August, September 21st. We have another equinox. So the rays are most direct at the equator again. You went winter, spring, summer. What do we have down here? Fall. So what would the southern hemisphere have? Spring. And then it repeats. So this is a diagram that includes the changes of the angle of the sunlight. We know that it's going to hit most direct at the southern hemisphere. So the less direct rays are going to come up here to where we are in the northern hemisphere. In our summertime, the less direct rays are going to go toward the southern hemisphere. In the spring and the fall, if you ignore the plants, the conditions are about the same. Kind of rainy, kind of cloudy, kind of cool one day, warm, then cool, then warm. Like you can't decide what season it wants to be because it's changing from one extreme to the other. It needs some time to adjust, right? So that covers everything in the instructions except for the caption. Captions are the little like blurbs, the little paragraphs you guys see with pictures in your book. I would like for you guys to take a few minutes and put this picture into words. How would you explain what we've drawn here? And on Monday, when we have a Google Meet, because we have a normal day, we'll talk about the paragraph and what you need to include in it. And then that way the people that are watching this at home can also fix their paper too.
So when is our next testing day?
Wednesday. Yeah. All right. So I'll let you guys work on that. And then whatever you don't finish
It's no more.
is part of the homework that's in the book.